Okay, good morning, one and all present over here. I, Dr. Hulas Tonde, Sresh College of Engineering and Technology, Chhatrapati Sambhaji Nagar, Maharashtra. I welcome you all in the sixth day of this AICTE Atal FDP on AI-driven advances in mechanical engineering. So, the, today the 11th session will start, and that will be delivered by Dr. Surendra Saini sir, who is presently working in the Department of Mechanical Engineering, University of Namibia. So I welcome you, sir, Dr. Surendra Saini sir. Now I would like to take this opportunity to introduce today's resource person, Dr. Surendra Saini sir. Sir has earned his BE and MTech from the reputed government institutes of India. Sir has secured first rank in MTech master degree. Sir has completed and Sir has earned his PhD degree in manufacturing engineering from National Institute of Technology, Allahabad, that is NIT Prayagraj nowadays. He is currently working in the Department of Mechanical Engineering and Metallurgical Engineering at the University of Namibia in the African continent. His primary research interests are in the field of laser material processing, additive manufacturing, welding, casting, and recycling of materials, and modeling and optimization using artificial intelligence techniques. He has authored more than 70 research papers in peer-reviewed international and national journals and conference proceedings. He has guided 4 MTech dissertations and 4 PhD research scholars and under the progress. He is also working as reviewer and editor of the various international journals and conferences. He has delivered uh, more than 20 expert talks and more than 20 conferences in the international journals and international conferences. He has delivered expert talk in several international and national conferences and training programs for the faculty members and the students. He has awarded several prizes and honors in various universities. Best Research Paper Award, and uh, he has also received the Best Innovative Project from the university. He is a life member of various uh, associations like the Association of Machines and Mechanisms, ISTE, associations of the ASME. He has more than 17 years of experience in the teaching and research. He is always open to new ideas and partnerships with the researchers and faculty members to work in the R&D field. So, sir is always available, means sir is always help the researchers for guidance and support. So, Dr. Saini sir, I welcome you to this FDP on AI-driven advances in mechanical engineering. So, on behalf of Sresh College of Engineering and Technology, Chhatrapati Sambhaji Nagar, I welcome you, sir. So now I hand over the session to you. You can start the expert session. So thank you for giving us time, sir. I welcome you. So I request all the participants to please listen with patience, and I hope this session will be a learning experience for all of us. So thank you, Dr. Saini, sir. Are you there, sir? Please start the session, sir. Dr. Saini, sir. Yes, sir. Your screen is visible, sir. Make it full screen and please start your session.
Dr. Hulas,
Yes, sir.
am I audible?
Yes, sir. Yes, sir. Audible, sir.
Okay.
Yes, sir. Please proceed.
Mhm. So hello to everyone. Once again, good morning. Esteemed management, director, deans, head of department, faculty members, researchers, and participants. Once again, good morning. It is a great pleasure and honor for me to join you all as a resource person at this ongoing faculty development program on AI driven advances in mechanical engineering. Before we start this session, I would like to be acknowledging Dr. PM Ardapurkar, coordinator of this Atal Faculty Development Program and Dean Academics, and Dr. Hulas Tunde, coordinator of this Atal FDP and head of a mechanical engineering department. So now let me start this presentation. And during this presentation, I would like to speak on a application of a artificial neural networks in a laser beam drilling, where we'll talk about a laser beam drilling. What is laser beam drilling? What are the key process parameters and the quality characteristics? All these things, and how artificial neural network can be used to improve the performance and the efficiency of this process. So these are the presentation outline where I will talk or discuss with a introduction of a laser beam drilling and what are the input process parameters and quality characteristics of a laser beam drilling process. Then we'll discuss about the key challenges, meaning what are the key challenges for laser beam drilling process with a traditional, especially with a traditional laser beam drilling process. After how artificial intelligence based artificial neural network techniques are being applied to overcome those laser beam drilling challenges and to understand the correlation between the input parameter and the quality characteristics parameter through the modeling and the optimization using this artificial neural network technique. Later, we'll discuss a case study based on a laser beam drilling using a artificial neural network. And finally, concluding this session with some future outlook and some fruitful discussion with the participant. Now, let's move to next slide. That is the introduction. So, in introduction of a laser beam drilling, or we can say laser drilling. What is laser drilling? So, laser drilling is a high precision, non-contact type thermal energy based process. It is unlike a mechanical drilling process where a focused laser beam is used to create holes in a different types of engineering materials. Materials means here I'm talking about metals, ceramics, composites, and polymers, where conventional and non-conventional drilling tools often failed. So in this process, a highly focused laser is used as a heat source to melt and vaporize the work material. And we know when a high energy or a intense laser energy beam strike or directed on to the work material surface, that melt and vaporize the material and produce a hole or cut the material that we want from the material. So as I said, this process can produce a high aspect ratio holes in all advanced engineering materials, including ceramics, ceramic composites, high temperature alloy, polymers or polymer composites, because of its remarkable characteristics. Like characteristics means like there is no mechanical stresses, or we can say the minimal mechanical stresses, because there is no cutting tool and no physical contact between tool and workpiece. That's why we can generate, or we can produce, or we can cut accurate hole features at a high speed. And this laser beam drilling process is very much useful for difficult to drilling materials. So here figure 1 shows a schematic diagram of a laser beam drilling, where a laser, where you can see here where a laser beam laser beam is directed on a work surface, and this beam is following or moving along the periphery of the hole that to be drilled in a material. So here you can see this the schematic diagram how the laser cut or drill a hole into a specified material. Yes. Mm. So Dr. Hulas, are we following?
Your voice is clear, sir. Please proceed, sir. Yes, sir.
Okay, thank you so much, sir.
Okay.
Now coming to next day, process parameters and the quality characteristics. So as we know, the performance and the quality of a laser beam drilling process are determined by several input process parameters and quality characteristics. So what are those several or the key input process parameters? Those affect the quality or the output parameter or the response of a laser beam drilled hole. So these parameters are the like laser power, pulse frequency, drilling speed, assist gas, type of the assist gas and its pressure, pulse duration, beam diameter. So first, what is laser power? So laser power means how much energy is delivering or is delivered by laser per unit time. That we call the laser power. Hmm? And then the pulse frequency means a number of laser pulses pass per second. That is the pulse frequency or the laser pulse frequency, and it also depend on the type of laser, what type of laser we are using, like a continuous wave or the pulsed mode laser, what type of laser we are using. So it depend on that also. Then drilling speed. So this drilling speed, generally in laser beam drilling process, we call it a scanning speed or the cutting speed also, which means how the laser is moving or the laser movement rate to cut the hole or to drill a hole, and mainly it affect the interaction time between a laser and the workpiece. Hmm? Then next is the assist gas pressure. So assist gas pressure means generally we can use the reactive type and the non-reactive type gas like argon, CO2, nitrogen. It depend on the again type of the material. So and its main function is to remove or to exit the or to expel the molten material from the drilled hole. Then coming to the quality characteristics. So here I only mention some specified quality characteristics of a laser drill hole. So as you can see, figure 2. So figure 2 shows the quality characteristics in a laser beam drilling. So figure A is showing the formation of a spatter. Formation of spatter means the molten metal re-solidify on a top surface of the material. So the material is, so here you can see the the drilled diameter or the drill diameter is not accurate. eh? And then figure B shows the bottom hole diameter. So again you can see here these are the challenges. So I was talking about those challenges, like in a traditional laser beam drilling there are many challenges. Still there are many challenges remains. So here you can see the diameter. Diameter is not accurate. It is not a circular hole at the bottom side. And then figure C is showing the hole taper. So again, it is a major challenge in a traditional laser drilling system or laser beam drilling process. So here you can see at the top at the top surface hole diameter and at the bottom side the hole diameter are not identical or are not same. So due to the formation of hole taper. So when a top diameter and the bottom diameter, when they are not identical or they are not same, then we can say it is a formation of hole taper or a tapered hole tapered. Then figure D is showing the thickness of a recast layer. So here you can see a thickness inside the hole, inside a hole. So this is a this is a hole. I think let me put my laser pointer. So hope now you, I think, okay.
Sir,
So here, yes, yes,
uh,
doctor.
my question is that, sir, means how to
Yes,
select
please,
these parameters for any means optimization process.
sir. Yes. So in coming slides, I will discuss that how
Yes.
to select, how to predict or how to select the optimal set of a process parameter
Okay, sir.
for a particular or for a specified material.
Yes, sir.
So in coming slide, we'll discuss that using a artificial neural network or
Yes, sir.
how can we select this process parameter.
Sure, sir. Sure. Okay, sir. Please.
So
Yes.
then figure E is showing the micro cracks. So again, micro cracks, formation of a micro cracks. So now we can see or we can conclude that the selection of a or the prediction of a optimal set of or the optimum setting of a input process parameter when we are performing the laser drilling on a particular or on a specified type of material, it is very important. Otherwise you can see we cannot get the quality of holes or we cannot produce or fabricate the quality holes. Like you see here, these pictures, these are my own experimental work that I am showing here, that the in a this is a case study uh, which was performed on a ceramic material. So you can see here, like in mechanical drilling, we can get a accurate hole size, but again in mechanical drilling, we cannot produce a hole in all type of material. There are again limitations. That's why we are looking, or the advanced technological industries, they are looking or they are seeking the process, particularly a process that can drill or that can cut a perfect hole in all advanced engineering materials. eh. So these are the challenges in a traditional laser drilling. So though there are other challenges are also, hmm, then moving to next slide. So these are some basic challenges or the common challenges in a laser beam drilling. So so far, if you have any question from the participant, then I can take few questions. So far, if you have any questions or if any feedback from the participant, okay. If there is no, then good. So as I said, the laser drilling has many advantages also, but however there are several technical challenges remains, such as a uh, selection and a optimization of a process parameter, meaning selecting and optimizing the process parameter for laser drilling, particularly for a given material or particularly for a specified material with a precise hole geometry is still a challenging or still a challenge. And again, when the number of process parameters increases, then their non-linearity interaction make this process again a complex. So because as a current industrial application also, as I said that advanced technological industry, they are seeking or they are looking for a precise drilling holes. Let me say example for a heat exchanger, machine tools, sleeves, they require a smaller hole diameter with a high aspect ratio and very close tolerances. But as I said in a previous slide, and I showed some figures also. This current or the traditional laser beam drilling process cannot meet these demands. Therefore, we have to look for another or a particular process. And next is the managing material response, which means in a traditional laser drilling system, it is very much difficult to manage or to manage or to control the laser drilling process parameter so that we can get a high quality holes or high quality holes characteristics. So it is difficult, it is difficult to real time monitoring and controlling the process parameters. So in a traditional drilling system, there is only a manual monitoring system or a manual controlling system, and this system to be integrated with a real-time monitoring and controlling system, and that is only possible in a integration of a smart manufacturing, especially the industry 4 node tools. So these are the some basic challenges in a laser beam drilling system, like a complex non-linear parameters relationship. When the number of parameters increases, then they form a non-linearity or the complex relationship between the input and the output. And our conventional optimization techniques, they are not have that much of capability, or they have their own limitation for predicting the process parameter range and a optimum set of the quality, the input parameters. Okay, and they have also more time consuming process or the techniques. Then moving to the next, that is our main topic of this talk or this presentation, that is the application of artificial neural networks in a laser beam drilling systems. So now to overcome these challenges that we have discussed or that I have mentioned, that a traditional laser beam drilling system facing lot of challenging, and establishing or developing a relationship or a mathematical relationship between a input process parameter and the quality characteristics with traditional mathematical models or the regression models, like a response surface methodology or the uh, Taguchi experimental method or the design method. Yes, sir.
ते वायर कुठे मग ते माहिती तू विसरून जायचा हो रोज की देतात हे वेळेवर तिकीट नाही डिप्लोमा पोरं पेपर दिले आपले तर नाही पण डिप्लोमाचे नाही दिले
Being
सध्या
very
ते
disturbance from the organizing side.
मी तो
Mute yourself. Hello.
Doctor, could you manage to Mute their
पीयूटी आणि माझ्या सब्जेक्ट ऐकून घे. मी फक्त पीयूटी माझ्या सब्जेक्ट गॅरंटी देतो. 4 टीचरची गॅरंटी मी देत नाही, सरांची गॅरंटी देत नाही कोणाची. पण प्रत्येक टीचरला भेटायचं तुम्हाला. वरच लाटवा ना त्या टीचरला परमिशन घे. मी मला सांगितलं की ठीक आहे भाऊ. हे तर खाल्ले होतं का? तसं नको करा नाही. ऍटलीस्ट
Can I start, sir, again? So, as I said that to overcome these challenges, of laser beam drilling systems, we can use the artificial intelligence, and where the artificial intelligence play a significant role in a manufacturing engineering, especially when we talk or when we are talking or when we are looking for a smart laser beam drilling system or the process where we can monitor real-time monitor or controlling or can send the real feedback to the machine or to the drilling system, and can perform the digital twins or the autonomous control that can help to transform what was in our traditional or what was a highly manual laser beam drilling system where the parameters, trial and error domains generally used. And so with the help of this artificial intelligence tools, we can optimize, we can adapt and control the process in a real time. That is the need of the current laser beam drilling system. So basically here I want to emphasize the major application of artificial neural networks in a laser beam drilling system that can control the process parameters in a real time, means during when we are performing the laser drilling on any type of material. So during the operation or during the process, with the help of ANN or with the help of AI tools, if we can monitor the parameters, we can control the parameters so that we can get the quality holes, and we can model and we can optimize means whether it might be a single objective optimization or the multi objective optimization. And as I said, the digital twins. What do you mean by the digital twins? Anybody from the audience or from the participant? What do you mean by the digital twins? Hmm? Can you answer so that it can be a interactive lecture for us? So digital twins means
The
yes, sir. Please go ahead.
yes, sir. Digital twin means, sir, the replica of the original working system.
Yeah,
Like,
it is correct. It is correct. Yes.
and that will
So,
interact with the human operator or human being.
yes, yes,
Yes.
yes.
For example, we
Yeah.
can make a system that will be a, that will be in a soft form, and that will be the replica of the maybe laser beam machining, and
Yes.
that will interact with the user, that what is the process parameters, what are the actual simulations going on during the operation, laser beam operation. Am I right, sir?
Yes, it is correct. It is very much correct. You are very much correct, and you explain it nicely. So, and in addition to, I just want to add that as doctor said, the integration of we can integrate when we integrate the artificial intelligence tool. So especially when I'm talking about the artificial neural network with a digital model, let's say finite element model simulation. So if you want to simulate the temperature profile or the temperature temperature, how much is the temperature is inducing or the generating during the laser drilling. eh? So integration of a ANN with a digital models so that we can simulate the process or we can control and monitoring the system. And then last is the diagnostic system. So diagnostic means exactly understand how the laser is interacting with a particular material, because nowadays the industry they are working on a different advanced material, particularly for the aerospace industry, for the medical industry, for the nuclear reactor, and for the, so there are many advanced materials. So how exactly the laser is interacting with
Sir,
the materials,
yes.
and they can self diagnose, they can self diagnose, they can self optimize the parameters, and can send feedback for the improving the process control. That is the diagnostic. So these are the basic application of a artificial neural network, particularly in the laser beam drilling system. So we can say in nutshell, uh, these are some fundamental applications or the major application of artificial neural networks. eh? Those are transforming this laser drilling system from a experience based laser drilling process. Experience based means earlier we use the operator experience. We are not using any uh, software or any any AI tools. We were totally depend on the operator experience. So these applications or these AI tools are converting the experience-based laser drilling system to a predictable and a optimized or the online or the real-time monitoring and the controlling process.
Sir,
So these are the,
sir, sorry
yes,
to
doc,
interrupt you. Uh,
yes, doc,
one of the participant, Miss Supriya Kumar, is also given the answer about this digital twin, and
yes, great, great.
she has written that virtual representation of a physical object, process
Yes,
or system.
it is correct. Yes, it is correct, sir. It is correct. And the present industry, they are looking for the digital twins. So
Yes,
once you rectify the problem, once you identify the defects or select the optimum parameters, then you can save your time, you can save your resources. There are many advantages. That's why the advanced technological industries, or the current industry, they are looking towards the AI. And AI nowadays you can see everywhere in every application, AI is dominating. So it's
yes,
the correct answer. That's the, yeah. Any other question, sir, from the participant? I am really happy that the participant are they are listening carefully and they are also interacting. It's a great uh, pleasure
no,
for
no
me.
further question. So please proceed, sir. Thank you, sir.
Okay,
Yes,
and also the literature study also reveals, sir, that a artificial neural network have become an effective
yes,
AI or the artificial intelligence tool in a manufacturing process, and especially in a all non-traditional or we can say uh,
yes, sir.
non-conventional machining systems or so earlier we were talking about the traditional machining system or the traditional manufacturing system. Then we improved or we talk about the non-traditional or unconventional manufacturing or the machining system. And now we are talking about the intelligent manufacturing system or intelligent manufacturing process in a mechanical engineering. That's why you really you choose a attractive topic or a current research based topic like AI driven mechanical engineering. So nowadays in mechanical engineering, AI is very much dominating, and that's why we are talking about the intelligent mechanical engineering or the intelligent manufacturing system or the smart manufacturing system. So using experimental data, the ANN can predict the relationship between input parameters and the output characteristics with a high accuracy. And to work on these all mentioned application like modeling, optimization, process monitoring, or the process controlling, digital twins, or the diagnostic using artificial neural network. So there are different types of artificial neural network. Though the types of or the selection of artificial neural networks depend on their application mainly. There are many artificial neural networks, but the selection of artificial neural networks depend on their application, their architecture, their learning methods. But broadly, we can say or we can group these artificial neural networks into three main categories. So, okay, I will come later on this slide. Let me just explain about the types of neural networks. So, in broader, there are three types of artificial neural networks, and each neural networks have their sub neural networks. So the first artificial neural network that is most widely used in the manufacturing, that is the feed forward neural network, which means when we feed the input or input something means our input parameter that we generally consider in our machining process or in our manufacturing process. eh. So input something at the input layer, and when it travel from the input layer to hidden layer, and then from hidden layer to output layer, that I will discuss later the artificial neural network structure or the architecture. So, but in feed forward neural network, generally we give the input to the input layer, then that the information or it travel from the input layer to hidden layer, then hidden layer to output layer. And there are different types of, again there are sub classification, or there are different types of feed forward neural network also, like a single layer perceptron, multi layer perceptron, radial basis, or so these are some different kinds of feed forward neural networks. So the selection of these networks depend on the application, the complexity of the data, or the non-linearity of the data. These depend on the our application or the uh, hmm. Then the most used, and again the second type of a neural network is the CNN. CNN means convolutional convolutional neural network, and then the next is a recurrent neural network, that is RNN. And there again there are many specialized neural networks, like a modular neural network, that is generally we call MNN, self-organizing map, that is SOM, general adversarial network. There are many like spiking neural networks. These depend on the which type of application we are dealing. But in our manufacturing or in our machining process, non-conventional machining process, when we talk about the AI, so AI, basically AI tool means our artificial neural network. So mainly we use the feed forward neural network for our manufacturing applications or eh. So these are some basic artificial neural network, as I said, feed forward, CNN, RNN, and the specialized neural networks also. So these are about the artificial neural networks, and those we can select based on the applications. Any question, sir? If so far, otherwise I can move to the next slide. Hmm? Any question, sir?
Yes, sir. Yes, sir. We are here, sir. Yes,
Okay.
this on. Yes, sir.
So as we discussed that the AI, the mainly artificial neural network role is or you can doc you can take any question from the chat. If
Okay,
is
sir.
there any question from the participant side, then we can discuss uh, before to move next slide. We can discuss if any relevant question or any if any participant want to discuss something about to this ANN, then we can discuss. Uh, otherwise,
Yeah, Mr. Dushyant Pawar sir is there. He want to ask one question. Pawar sir, you can ask questions, sir. No problem.
yes, please, sir.
You can write also in chat box.
Okay, let me just
Sir
check.
Dushyant Pawar sir, are you there? Hello. No, sir. Okay, he is not available. So please proceed, sir. Yes, sir.
Okay, thank you, sir.
Yes.
So as I said that the role of
Dushyant
artificial
Pawar sir, I
intelligence
have
or the
unmuted you. Dushyant Pawar sir, I have unmuted you. You can unmute, please.
okay, now it's fine, sir.
Yes, sir.
Yes, sir. Please.
Yes, sir, please.
Yes, sir. Yes, sir, if I use an auto encoder method for artificial network for giving an input parameters, so
Mm-hmm.
by due to the real monitoring system, it will be taken automatically inputs from the system and can be giving the output on that basis system.
Yes, sir. That's why, as I said, that these are some specialized neural networks. Like
Yeah.
there are many auto encoders. So on real time, you can monitor and you can control the laser drilling system or on any type of a manufacturing process. And based on that, a predicted value of the process parameter, you can get the quality parameters or the quality response means the quality desired quality on a
So
particular process.
as being
Yes,
and I change the material time to time, and by real
yes,
monitoring system, I put some by default parameters to it. So can it will be able to give me the optimized parameter?
yes. But you have to again when we are designing the special network, like as you said, the auto encoder, huh? So
Yes, sir.
there you have to decide the you have to choose or you have to also program or you have to give the material property because if suppose if you program or if you just select or you design a specialized network like a auto
Yes,
encode using auto encoder. So if you design
yes,
for a particular material and on machine you set a different type of material, then you will not get the correct result. Getting my point? So you have
yes,
to specify the material property when you are designing
yes.
the particular network. Once you design or give the particular material property, then you can get the quality parameters.
Yeah,
Yes,
is like it that material library I can proceed for in the my programming, and then switch
yes.
over the different materials so it can be monitor the systems real timely, and then
No,
it will
no.
be
Mm-hmm. Yes, yes,
just
sir.
like a different material library I can put up in the my programs with
Yes,
all
then
parameters.
it will automatically detect. It will
It's
automatically detect like in our CNC system. We just
yeah,
first we give the input like okay,
yeah,
this is my this is
four
the
or
range
five
of my
materials.
input parameters, and
Yeah,
then it will automatically detect that on what material we are going because again to make it smart or the industry 4.0 means there is a sensors. There are many smart tools that will detect that on which type of material we are going to perform the process particularly. So that network can detect all these information and then set the parameters, the input parameters. That is the self diagnosing or the self optimizing the parameters.
Okay. Thank you, sir.
I hope you got my point.
Yes, yes, sir. Definitely. Okay. Thank
Oh,
you, sir.
thank you so much. Okay, it's pleasure, sir. So okay. So Dr. Hulas, any other question? It's a really, I am also very much excited to interact our participant, and it's
Hello,
really a
sir.
good.
Good
Yes.
morning,
Please,
sir.
you can proceed.
I have one question about can we implement this AI artificial neural network for optimization of WDM process parameter?
Yes, sir. Yes, sir. You can. Though I'm just this talk I just specify for the laser drilling system, but laser drilling system is also a manufacturing type of a manufacturing process, or it is a non-conventional process. And as I said that earlier, we were talking about the traditional manufacturing process like a, turning process, drilling process, all milling based process, all grinding based process, surface finishing process. Then we moved on a non-traditional process using all our EDM based operations, laser beam based operation, meaning the based on the energy or the based on the type of so then now in current time or currently we are talking about the intelligent manufacturing system. Though our machining is same, everything is same, we are not changing anything, just we are making our non-conventional or the conventional manufacturing process just smart, integrating with the sensors, transducers, cameras, everything. You can implement, sir, you can implement on your EDM or wire EDM, all type of manufacturing process you can.
Okay, sir.
Yes.
Mm.
Thank you, sir.
Thank you, sir. Yeah, required your help. I will communicate with you, sir.
Definitely,
Okay.
sir. Anytime you can contact and we can do some good work on
Okay. Thank you, sir.
that area. Yes. Yes, sir. Any other questions from the participant side?
No questions, sir. Thank you for answering these questions. Thank you, Deepak Kharab, sir, and Dushyant Pawar, sir, for your interaction. Other participants are also requested to please ask questions, interact with sir. We are definitely discuss your queries.
Yes, sir.
So, thank you, sir. Please proceed further, sir. Yes. Sir.
Okay. Thank you, sir,
Yes.
for this. Then, as I said, that the role of artificial intelligence, in particularly laser beam drilling, or we can say, as we discussed, that nowadays the AI is dominating in all manufacturing process, not only in the machining, but it is also dominating like a smart casting process, smart welding process. As you see nowadays, the laser beam drilling, ultrasonic drilling, ultrasonic welding, laser beam welding, and there are many advanced welding process, friction stir welding process, and the recycling of the materials also. So AI is now dominating, and now we have to also just move on all these things, and we can how we can make our machines more smart, uh, so that we can get a high quality characteristics in all manufacturing process. So as I said that artificial intelligence means it is not only artificial neural network, but there are other many AI based technique like a machine learnings, deep learnings, fuzzy logic. There are many optimization algorithm those offer the or the address these all these challenges, and the parameter optimization, predictive modeling, means AI, many AI techniques they can just learn from the prior experiments or the prior experimental data set through the sensor, and then after they can predict the quality outcomes. Quality outcomes means if we talk about the laser drilling system, then the what will be the accurate hole diameter or the hole circularity with a high surface finish and a minimum geometrical dimensions for a particular parameter combination. Thereby, we can reduce the number of or the need of number of our trials or the time consumption or the exhaustive trials. Then there, as I said, also the real-time monitoring and the adaptive control. It means how can we integrate the sensors or cameras or the thermal imaging so that we can analyze the temperature also with the help of a thermal analyzing tools, so that we can obtain the process data or the data driven using these tools, and how can we adjust the parameters dynamically. So these are the basic roles of a artificial intelligence in a manufacturing process. And we also discuss about the digital twins. How can we incorporate the digital twins or replicate, as one of the participants said, the virtual replicates of the physical process or the particular manufacturing process. How can we combine with AI tools so that we can simulate the process, we can predict the process parameter that can help to speed up the process or the optimum parameter setting and all these things. Then how can we also, these tools can help to maintain the machine or the machine health also. So these are also very important for monitoring or the maintaining the machine, particular machine. As one participant said, that how can we implement these techniques or these tools on a EDM process. So we can add by adding all these smart tools, sensors, cameras, thermal analyzing systems, or the thermometers or the pyrometers. There are many smart tools that we can integrate, and then we can analyze the process. We can make our process or our system more smart. Now, moving on a case study. So this case study is my own experimental based case study where we perform some laser drilling on a ceramic plate using or varying some parameters, and then we develop a model using artificial neural network. So first let me explain the brief about the artificial neural network. So it is a artificial intelligence based tool or technique which was inspired or is inspired by the human brain. So it just mimic the human brains, and these networks are capable to capture all complexing complex complex data nature, non-linearity relationship between the input process parameter and the quality characteristics. So basically, the artificial neural network work on the how our human brain work. So it just mimic from the human brain working process. So to implement this artificial neural network, you can see figure 3. Figure 3 shows the artificial neural network architecture, and this figure consists 3 layers: input layer, hidden layer, and then output layer. So hidden layer means hidden layer represents the process parameter. Process parameter means what are our input parameters. So in this case, the input parameters are there are 4 input parameters, namely lamp current, pulse width, number of pulses, gas pressure. Gas pressure means here the assist gas pressure that was used to exit the molten material from the drilled hole. So input layer represents the number of input parameters. Then the second or the middle layer is the hidden layer that represent or that process the or transforming the data using a weight and a bias. So here from when we process or when we train this network, then the weight and the bias values generate. And then the last one is the output layer. This output layer represents the quality or our output response. So in this study, the output value, the output response or the quality characteristics is a whole circularity. There might be different output parameters, like as I said when we were talking about the quality characteristics in a laser drilling system, like it might be recast layer, surface roughness, hole taper, circularity, micro cracks. There are many. So this figure, this figure 3 showing the basic architecture of a artificial neural network, and figure 4 is showing the fitting of graphs. Fitting of graphs means the predicted value, how the predicted values or the predicted values of a whole circularity fitting with a actual experimental values. So here this figure you can see the x-axis representing the number of experimental run, and the y-axis is representing the actual and the NN predicted values. So here this figure you can see the curve is fitting, and the predicted values are well fitted with the actual experimental values of a whole circularity. So basically this is the ANN architecture, and the predicted value as were compared with the actual values. Then this figure 5 shows the basic implementation steps. So using the MATLAB, you can also perform, and you can perform this artificial neural network. Artificial neural network for a particular problem, and then then you can predict the range, or you can predict the setting of a input process parameter for a particular application. And then so before conclusion, I will here I want to mention one more thing, that the accuracy or the accuracy of ANN model or the ANN tool is much higher than the conventional modeling tools. Here you can achieve the model accuracy more than 95%, or sometimes in some literature or the literature study reveal that artificial neural network can give more than 99% accuracy also, in comparison to conventional or the traditional modeling tools. So now let's move towards the summarizing or concluding this session. So as I said, laser beam drilling is a thermal energy based non-contact process which is best suitable for all type of engineering materials, including high temperature alloy or the super alloy, or the composites, polymers, all difficult to cut materials. And the performance of this process is highly depend on the control of a process parameter or the input process parameters. And the AI based artificial intelligence based, though there are many AI tools, but the ANN can serve as a powerful AI tool for modeling and the optimization of a laser beam drilling parameters. And it can also effectively model the complex, or it can capture the non-linearity of a process parameters and the quality characteristics, and it can develop accurate mathematical relation, or the correlation between the input parameter and the output parameter. So we can monitor and we can control on a real time uh, parameters. And this tool, we can also integrate this tool with other AI techniques like fuzzy logic, genetic algorithm, or the any other. There are many more simulated annealing. There are many advanced optimization techniques. So we can integrate this ANN with other optimization technique also. eh? And as I said, the traditional laser beam drilling based on experience and trial and error methods can be transformed into artificial neural network enable data driven laser beam drilling to predict or to optimize the process parameters. So now coming to these are some future trends. In future trends, for a manufacturing process, or especially in a laser beam drilling system, we can monitor or we can control the process parameter using sensors, using that I have already mentioned. There are many uh, smart tools, AI, for those were captured in the AI for node or the industry for node already, and it can adapt the control system. And as I said, nowadays the industry, they are developing a hybrid models uh, comprising more than two or more than one AI based tool, and also they are integrating the Internet of Things for a industry for node application to make a more smart manufacturing process. So with this, I would like to just here finish this session. Thank you so much for your attention and participation. I hope this session provided you all a valuable insight into laser beam drilling and its application of artificial neural network, especially in laser beam drilling system. Thank you so much. Now I am stopping here. And this is my email ID. You may contact on this email ID, through this email ID, for the future collaboration or for future any fruitful collaboration. Now I am looking forward to your questions and the fruitful discussion, if any. Thank you so much, Dr. Hulas, for this wonderful opportunity.
Thank you, sir. Thank you, sir. We are thankful to you, sir. You given your time, precious time, sir. So,
Yes, sir.
dear participants, if you have any query, please write on chat box, or you are free to unmute yourself and discuss your query with the sir. Dear participants, please unmute yourself and you can discuss with us.
So, Hulas, sir,
Yes, sir.
did I complete in your scheduled time, or just I finished before your scheduled time?
No, no, sir. Exact time. This you have completed at the right time, sir.
Oh,
No,
thank you so much, sir.
thank you, sir. So
Yes.
it's time for the audience participants to ask the questions if they have any query.
Yes.
Wait for 2-3 minutes. Then we will go for the vote of thanks.
Okay. Should I stop my sharing PPT?
Yes, sir. Yes, sir. Stop. No problem.
Yes, sir. Any question, sir?
Sir, one of our friend want to ask some question because he's also working on the laser beam machining process. So,
Please, sir, proceed.
Surendra sir, good afternoon, sir.
Sir, good afternoon, sir.
I'm working on the laser beam machining only, on laser beam machining of polymer. So,
Yes, sir, please.
can you suggest me which AI tools or AI models should I adopt in finding out the or optimizing the parameters for this laser beam machining?
Sir, the best parameter or based on the literature study, I would suggest you can use the feed forward neural network for the prediction. And once you develop the uh, predict the predict the setting or the range of process parameter, then you can develop a mathematical model or a mathematical equation between a input parameter and the output parameter, and then you can use as a objective function that that mathematical equation as a objective function to optimize that optimization using a genetic algorithm, or you can use the fuzzy logic, or you can use nowadays there are, but these two techniques are more reliable, more yeah, they are very much simple for beginners, so you can, I would suggest that you can use the artificial neural network and the genetic algorithm, though you can use the fuzzy logic also, though there are many other technique also like simulated annealing, TLBO, there are many nowadays, but these two techniques are the more reliable, widely used, and they are more, yeah, I hope you got my point.
Yes, sir. Thank you, sir. I've got your point.
Yes, sir.
any other participant who want to ask, sir? You can ask questions, sir. No problem. Vishant Patel, sir. Vishant Patel, sir. You have any query? You are not audible, sir. Please unmute yourself first. Okay. Done Lakshman, sir. Are you there? So, since there is no query, so this is the time for the vote of thanks. So, it is my distinct honor and privilege to deliver the vote of thanks on this session. So, today we had a profound opportunity to listen to an incredibly insightful and engaging session on the uh, artificial neural net uses of the artificial neural network in the laser beam drilling and various machining processes. So, sir, I would like to thank special thanks to the today's resource person, Dr. Surendra Saini, sir. He had joined from the University of Namibia. So, thank you, sir. On behalf of Sriyash College of Engineering and Technology, Chhatrapati Sambhaji Nagar, I extend our deepest gratitude to the resource person, Dr. Saini sir, for taking the time out of their busy schedule to enlighten us and given the informative session.
Sir, actually, at what time test will be conducted?
Evening time, sir. It will be conducted at evening time. We will share in the WhatsApp group and mail you the link in the mail you also the test link. Sir. It will be happen in the Google form through the Google form.
Google Form. Okay. Yes.
Yes.
At what time exactly?
Sir, actually the evening, sir, it will be 4 to 5 p.m. between the
Yes.
4 to
Yes. Yes. Okay. Okay.
Yes.
Thank you, sir.
Yes, sir. So I would like to thank our resource person on behalf of Sriyash College of Engineering and Technology, especially the clear differentiation between the uh, uh, artificial neural networks and various other uh, techniques of optimization and in relation with the smart manufacturing, smart machining processes, and other things. So this was a truly illuminating session in a field that is constantly evolving, and that is the need for the modern manufacturing and material sciences. Your ability to given the talk in this session is extremely appreciable, sir. So this is the highly commendable. You have successfully sparkled the curiosity and provided the clear roadmap for the all the participants. So I request all the participants to please open your video. We'll take a screenshot that will be for our record for all of you, all of us. So thank you participants for being over here. Without you, this FDP will not be possible. So thank you everyone for being part of this FDP. So please open your video so that we can take a screenshot. So thank you everyone, and I request that please be the part of the next session will be at 2 o'clock, and we will meet at link will be the same. Dear participants, link will be the same. We will see you all of you at 2 p.m. So thank you for joining us. We will see in the 2 p.m. And the valedictory session will be held at the 4:30 p.m. And the test will also be conducted at the 4 to 5, between 4 to 5. So thank you everyone for being over. Surendra Saini sir, thank you so much.
Sir, thank you so much, sir.
India, from that country, sir.
Yes, sir. And we'll meet you, sir, on in next month, December.
Sure, sir.
So, yes, thank you so much, sir, for this wonderful opportunity. I really appreciate. Sir, once again. Thank you so much, sir.
Thank you, sir. Thank you so much.
Yes, thank you so much.
Participants, you can leave the meeting, sir. Thank you. Yes.